Now let's look at compound inequalities. So a compound inequality, think about what you know about English. A compound word like houseboat, houseboat, compound word. It's a house, it's a boat, it's a houseboat. So there's two words combined, make a compound word. Compound inequality, there's two inequalities. We combine them to make a compound inequality, okay? So compound inequalities are two inequalities that are joined by the word and or by the word or. You can represent compound inequalities using words, symbols, or graphs. So I've got some examples here in our table. Verbal description, the first one. If I'm talking about all numbers from 3 to 8 inclusive. Inclusive just means also including 3 and 8. So I could take that statement and I could say all the numbers x that are greater than or equal to 3 and all the numbers that are less than or equal to 8. Any number that fits both of those would represent all the numbers from 3 to 8 as a verbal description. Look at our graph. You've got closed circle on 3 and closed circle on 8, and then it's shaded in between. So if I was telling you all the numbers between 3 and 8, I don't mean 2, and I don't mean 9. I mean all those other numbers in between, and that graph does exactly that, as does our inequality. Let's look at the second example. All numbers less than 5 or greater than 10. That would look like x, all the x values that are less than 5, or, that's pretty obvious, all the numbers that are greater than 10. X is greater than 10. Look at our graph. We do have open circles. It's pretty faded, but it's an open circle on 5 and 10, and then it's shading opposite directions. This is where x is less than 5, and 10 is going out. This is where x is greater than 10. The third verbal description, all numbers greater than -1 and less than or equal to 4. So first statement, all numbers that are greater than -4, like x is greater than -1 and that is less than or equal to 4. Let's try on a number line. Okay, so probably your whole life working with inequalities, the teacher's like, then graph your inequality on a number line. And maybe you were like, why? It just seems so pointless. Why are we putting it on a number line? Okay, with compound inequalities, the graph ends up helping us check our work. It's actually really useful. So let's see. Make me a number line. Don't judge it. It's beautiful. All right. On -1, we have open circle, and it's all the x values that are greater than. So it's going to go that way. I'm not going to keep going because we're going to have like a little range on our graph, but I want to double check my inequality symbols. X is less than or equal to 4. That's closed circle. And less than this way. Perfect. They should be going that way. Open circle, shaded, closed circle. Beautiful, beautiful. Let's try one more. All numbers less than or equal to 3 or greater than 6. All numbers less than or equal to 3 or numbers that are greater than 6. All right, beautiful number line, right? Close circle on 3, and it's less than. Open circle on 6, and it's greater than. Perfect. All the numbers that are less than or equal to 3 or greater than or equal to 6. Now, some things I want to go ahead and point out to you before we get any further into the notes is notice where it was and, all of these were ands, the shading was right in between. And anywhere it was or, they went opposite directions. You see that? That's going to be helpful for us to check our work to make sure if it's a compound inequality joined by the word and or, we we know which graph it should look like. Ands overlap and they are shade in the center with each other. Ors shade opposite directions. And you want to know my memory device? It's really awful. Ors are like oars on a boat. They go opposite directions. If this was my boat, you think it's cute? It's great. Yeah. So on those or inequalities, they should be shaded opposite directions because I want that or I want that. And says I want them both to happen, both inequalities to happen. So they're going to have to be shared values. I think we've got that wording below. The first one here, looking right there, compound inequalities that contain and have solutions that make both inequalities true and their graphs overlap. Give us a doodle. Little doodle where they overlap, right in the center. Okay? Compound inequalities that contain or have solutions that would make either inequality true. This one or that one, I don't care. And so it's going to show each inequality, like the oars on my boat. They're going to go opposite directions. So that's what I was saying. You kind of want to graph them so you can see and make sure your inequality symbols are right, that it's doing what it's supposed to be doing. And so let's look below. Solve each inequality and graph the solution on the number line below. Number 1, what? Ms. Bryan, you did not show us this. What is this? Okay. Number 1 is kind of a classic compound inequality. It is literally two inequalities that have been shoved together. So let's unshove them. Let me also mention this notation where they are shoved together can only be used for and compound inequalities. I'm going to put that on our notes. Shoved together are and inequalities. I have students in the past that want to shove them together. They look really cool, and so they always want to shove them together as their final answer, and you cannot shove together ors. You can shove together ands if you want to write it with the word, or if you want to shove it together, it doesn't matter. But you can't do it with or inequalities. So let me unshove it. I've got negative 50 is less than negative 5x minus 5. And I've got negative 5x minus 5 is less than negative 25. Both of those are there. So what are we going to do? We're going to solve each of them. Solve each of them separately. So I'm going to focus on the left one. I'm going to solve for x. So add 5 to both sides. Divide by negative 5. Divide by negative 5. What? Negative 45 divided by negative 5 gives me positive 9. And I divided by a negative. Flip your sign. Then let's go over to the other one because I've got an inequality. If you want to go ahead and graph it, you could. Let's go to 9, open circle. Remember, flip this over. This says x is less than 9 if you need your arrow to point you in the right direction. And I'm just going to start it because this was an and. I'm going to have a center overlap graph. It's going to keep going. Let's see where they overlap and what they share. So on the right one, very similar, adding 5 to both sides. Negative 5x is less than negative 20. Divide by negative 5. Divide by negative. X is greater than, flip it, 4. All right. So go to 4. Oh, it's right there. 4. And it's all the values that are greater. So it's going to the right. And there's where they share. I've got an open circle on 4, open circle on 9, and they're shaded right in the middle. Let me see if I can make that any better. Shaded, open circles. We're trying to make it beautiful. Yes? So if you want to shove them back together, like I said, I have students that like to shove them back together. Just take these two pieces and share the x. So 9 is greater than x is less than 4. But wait, hold on. If I'm going to make you a fabulous mathematician, I got to tell you the truth. Now, this is only proper notation if you go from smallest number to biggest number. So flip it all over. 4 is less than x is less than 9. Look back at the top problem. Less than symbols, okay? You always have to have less than symbols if you're going to shove them together. That way the numbers are in order from least to greatest. It's proper mathematics, so I want to make sure you are learning it right. I'm going to erase those lines so it doesn't look funny. So if you're going to do that, make sure your final answer has less than symbols and your numbers are from least to greatest, okay? These answers up here were perfectly fine as well. All right, let's try another one. Number 2. You've got 3x plus 5 is greater than 11 and 3x plus 5 is less than 32. So we could have shoved this together if you're curious. It could have looked like 11, pancake it over, less than 3x plus 5 is less than 32. Notice the less than symbols. Notice 11, 32 is in numerical order. There you go. But we're going to need to solve them. So let's do that. Now this is an and problem. So when I am done graphing, I should have an overlap where they're in the center, not ors going the opposite direction. So let's see how this turns out. 3x plus 5 is greater than 11. 3x plus 5 is less than 32. All right, solving the left one, subtract 5 from both sides. 3x is greater than 6. Divide by 3. X is greater than 2. On the right side, I'm going to subtract 5 from both sides. 3x is less than 27. Divide by 3, divide by 3. X is less than 9. Okay, so there's our two answers. You could shove them back together as an and if you wanted to, not required. We would have 2 is less than x is less than 9. Notice the less than symbols and 2 and 9 are in numerical order. As I graph it, we've got open circle on positive 2, open circle on 9. Now this was an and problem, so it should be shaded in the middle. Let's see what happens. X is greater than 2. That one's going to go this way. And x is less than 9. This one's going to go that way. Perfect. They're going to shade right in the center. Shading right in the center. We've got open circle and open circle. Okay. Number 3 is 10 is greater than or equal to 4x minus 10, or 22 less than or equal to 4x minus 10. So when I finish, my graph should be going opposite directions. Okay. These are already separated. They cannot be shoved together. I'm going to put that here. Don't do it. Oh no, I know. But it's so cool, Miss Brent. I'm sorry. All right, so on the left side, we will need to add 10 to both sides to give us 20 is greater than or equal to 4x. Divide by 4. 5 is greater than or equal to x. There's our first one. On the other side, add 10 to both sides would give us 32 less than or equal to 4x. Divide by 4 would give us 8 less than or equal to x. Now this is an or statement. Cannot shove it back together. So let's see what we have. If you need to use the inequality symbol to help point you in the right direction, flip this over. So it's x is less than or equal to 5 and x is greater than or equal to 8. So let's go and graph it. On 5, we're going to have a closed circle. I think this is our first closed circle on these problems. And x is less than that. On 8, also a closed circle, and x is greater than that. So perfect. They are going in opposite directions on the number line to represent an or compound inequality. Perfect. Now you cannot shove those together. You can only combine them using the word or. So that is compound inequalities. Again, they are combined using the word and the and ones can be shoved together where they share that commonality, but When you are writing a combined and inequality, you have to use less than symbols so that it's in order from least to greatest. And then it can also be combined with the word or, and only in those cases you have to use the word or. There's no other fancy math way to do it. But it's just two inequalities that were combined together. So just separate them, solve them separately. Do check your graphs. Now, if these problems had negatives in them, which we did on number 1, and you forgot to flip your sign, when you go to graph, you're going to see funky stuff happen. So that's why graphing is actually really helpful on compound inequalities. If it's not graphing an and, if it's not graphing an or like it should, then double check your work. There's probably a mistake in your math. So compound inequalities, let me know if you have questions. These are going to come back. We're going to need compound inequalities in the next lesson or so. So I'll see you later. Bye.